LinkedEarth is all about making it easier to work with paleoclimate data. We live in an information age, and there is a lot of that data around, but it's typically very difficult to work with. And I see paleoclimate data as an untapped treasure trove of information that's going to help us unlock a lot of secrets about how the climate system works. But when we began this 10 years ago, it was just very difficult to work with.
The project originated over frustration about the use of data in paleoclimate to be able to do analysis. I was sure there was a better way of doing this than what was done in the past. And now the mission is to actually make paleoclimate science easier, faster, and essentially help people with their paleoclimate questions.
And our mission continues from there. We've done a lot of work making lots of data sets, thousands of data sets open and available. We've developed a lot of analysis tools to make those data easy to use, and we brought a lot of people together through trainings and community activities to train them to use these tools and use these data and participate in this effort going forward.
One of the ways to make that happen in practice is to have data standards, where you basically have the community come together and decide what do they think is important to report, how to report it, do we agree on the nomenclature, what we call things, as well as having tools that can hold all that information.
There are a whole range of tools that LinkedEarth has developed, that this community has developed. The ones that I've engaged with the most are the lipid data format, the linked paleo data format, and the data standards that are associated with that, so controlled vocabularies. And I've used that data format both to store data that me and my team have generated, and then I've also engaged with that data format when I've worked on global and regional syntheses of paleoclimate data.
They're very helpful. There's a huge amount of training materials and tutorials out there. But once you get your head around the basics, it makes future science a lot easier and can really open up new avenues of robust and reproducible paleoclimate research, remove a lot of the statistical and coding overhead that otherwise comes with starting big data projects from scratch.
All of our code is open source. We share it widely and allows people to actually tell us there are issues with the code so that it becomes a community resource and doesn't stay essentially in the hand of two people. The idea of LinkedEarth was to make the data more accessible, more available to the broader community. So that means we need to have collaborations.
One of our strongest collaborations has been with the National Oceanographic and Atmospheric Administration. The lipid data standard, the linked paleo data standard that Nick McKay and myself originated, is now a recognized data standard by NOAA, and that's a format that they accept for people to make submissions.
We worked a lot with a group called PAGES, so that stands for Past Global Changes. It's an international organization that brings paleoclimate scientists together to do work, but a lot of that work often involves these data compilations.
One of the projects that we have right now is to help people create new data sets using essentially the data that they can find on repositories such as the NOAA repository or Pangea in Europe, and actually facilitate that process for them.
We're really excited about the future of LinkedEarth. We have a lot of ongoing projects that are nearing completion and maturity. One that we've been working on for the past 5 years is called Presto. It stands for the Paleoclimate Reconstruction Storehouse. And the big idea there is to combine a lot of the things that LinkedEarth has done over the past decade into a tool that's easy for people to use. It brings data and analytical tools together and can create custom climate reconstructions and distribute them broadly to the community in a way that's really easy for people to use and reuse.
The future for LinkedEarth, I think, looks very bright, especially with advancement in AI. The goal of LinkedEarth is always to make science faster, better, and with open source tools. And artificial intelligence and large language models are helping us with this. So really what we're looking for in the next few years is the development of a tool where instead of you being in front of your computer, figuring out the data, figuring out the code, you'll be able to talk to the AI. It's called PaleoPal. So you have a pal with you that actually helps you get that analysis pipeline done by helping you code, helping you find the data, helping you essentially with that LinkedEarth ecosystem. But all you have to do is speak in English.
We've been at this for 10 years, and we now have sort of a critical mass of data standards, data compilations, and tools that build on all of that. And I think the next frontier is to really bring AI into the picture, which is happening through the PaleoPal project. But overall, I think really the goal is to merge these different aspects of climate science. The future of LinkedEarth for me is that paleoclimate is understood as an integral part of climate science. And so it's more integrated into the overall arc of the discipline as opposed to being its special separate domain.